All right, so you've always wanted to build your own video game, right? But maybe you had no idea where to even begin. Well, guess what? This is the explainer for you. We're about to break down a really cool first project that takes simple lines of code and turns them into something you can actually play. So yeah, let's get those engines started and dive right in.
So what are we building? At its core, it's exactly this, a simple top-down 2D driving game. Think of those classic arcade racers from back in the day. Super fun, super simple. But the best part? This time, you're the one building it. You're in the driver's seat of development, and honestly, it's the perfect place to start your journey.
And that right there, that's the most exciting part, isn't it? We're not just talking about playing a game, we're talking about building your very first game. This is where you write your first lines of code. It's that huge leap from being a player to becoming a creator. And you get to watch your ideas literally come to life on the screen. It's an awesome feeling.
Okay, Section 1, your first driving game. Let's get into the specifics of what exactly we're going to be building here.
So, here's the deal. You are a delivery driver. Your mission, should you choose to accept it, is to pick up packages and deliver them. That's it. You'll navigate the world, find the package, and then race to drop it off. It's a really simple idea, but trust me, it's the perfect way to learn all the basics.
All right, on to Section 2, the rules of the road. Every game has them, and here we're going to break down the core gameplay loop, the stuff you actually do in the game.
And here it is, the whole gameplay loop, nice and simple. First up, you got to grab the package. Then, hey, you want to go faster, right? So you hit a boost. But you got to be careful. You've got to avoid bumping into stuff because that'll slow you right down. And finally, you make the delivery. That's the game. Grab, boost, avoid, deliver. Super clear and really fun.
Okay, now for the really cool part. Section 3, code under the hood. Let's pop that hood open and see what makes this thing run. This is where we connect what you see in the game to the actual programming concepts that bring it to life.
So let's look at our first game event. When your car drives over a package, two things happen. You pick it up and your car's color changes. It's a super clear signal to you, the player, that you've got the goods. But how does the game know it has the package? How does it remember to change the color?
Well, that's where the C# concept called a variable comes in. The easiest way to think about a variable is like a little labeled box. It's just a container for storing a piece of information. So we could have a variable called, say, hasPackage, and another one called carColor. When you pick up a package, our code just flips the value in the hasPackage box and swaps out the color in the carColor box. It's how programs remember things.
Okay, next event. You're driving along and bam, you hit a wall. Your car slows down. It feels like a real collision, but how does the game know that your car just crashed into something? How does it detect that physical bump?
The magic here is a Unity concept called a collider. Just imagine an invisible shape that wraps around your car and another one around the wall. The collider is what defines the object's physical boundaries. As soon as those two invisible shapes touch each other, Unity's physics engine goes, whoa, a collision just happened. And that's our cue to write some code that says, okay, slow the car down. Now, what about the opposite? You drive over a glowing boost pad on the ground and your car suddenly speeds up. But think about it, you don't crash into the boost pad, you just drive right through it. So this is a totally different kind of interaction, right? Yep, and for that, we use something called a trigger. Now, a trigger is basically a special kind of collider, but you tell it, hey, don't be physical, don't block anything. All it does is watch its own space. And the moment something enters it, it yells out, hey, something's in my zone. It's perfect for things like boost pads or checkpoints, anything you want to happen without an actual crash.
So check this out. The game knows when you hit a wall, and it knows when you drive over a boost pad. But how does it know what to do? How does it decide to slow you down for one, but speed you up for the other? How does it make that choice?
This is where the absolute core of all programming logic comes in, the if statement. Seriously, this is like the brain of your game. The code just asks a simple question. If the thing I just hit is an obstacle, then slow the car down. Or if the thing I just drove into is a boost pad, then speed the car up. It's how your game makes all its decisions.
Okay, so we've got variables to store our data, and we've got if statements to make decisions. But you can imagine, if we had to write out all the steps to slow the car down every single time we needed it, it would get super messy, super fast. So how do we package all that up into neat, reusable chunks of code?
The answer is another C# concept called a method.
A method is just a named block of code that does one specific thing. So instead of writing out all the code for speeding up again and again, we just create a method, call it something like increase speed, and stick all the instructions in there. Then anytime we need the car to speed up, we just say, hey, run the increase speed method. It keeps everything so much cleaner and more organized.
Okay, one last big piece of the puzzle. This one is super important. We've got this script file with all our cool logic in it, our variables, our methods, our if statements. But how does that script actually talk to the objects in our game? How does it reach out and change the car's actual color or mess with its engine speed?
Well, in Unity, this is done by getting components. Think of it like this. Your script needs to get the phone number for the part of the car that controls its color. That part is called a component. So the script says, hey Unity, give me a reference to the car's color component. Once it has that reference, it can call it up and tell it what to do, like, hey, turn green now. It's the bridge between our code and the game itself.
So let's wrap this all up. Section 4, your developer toolkit. We're going to recap all the fundamental skills you now have just from thinking through this one simple game.
And look at that! That's your starting toolkit. You've got C# fundamentals like variables to store information, if statements to make decisions, and methods to organize your code. And on the Unity side, you've got colliders for physical crashes, triggers for special zones, and you know how to get component references to make your code actually do stuff in the game.
And here's the most important thing to realize. These aren't just tools for making a delivery driver game. Not at all. These are the absolute fundamental building blocks for making any game. A platformer, a puzzle game, a massive role-playing game, they all use these same core ideas.
So that really just brings us to the final and honestly most exciting question. You've now seen the fundamentals, you have the tools in your toolkit, so what are you gonna build with them?